Hey guys, I'm going to continue with 12.1. We're going to be talking more about identities and inverses. So let's look at this question. Let's notice here that these two are additive inverses, right? 14 and negative 14. 5 and negative 5 are additive inverses. 0 and 0 is the identity, so it's always it's its own additive inverse, right? 0 plus 0 is 0. Negative 2 plus 2, they're also additive inverses. So these two since every element of the matrix is an additive inverse, or additive inverses of each other, so the whole matrix are additive inverses. So this matrix is the additive inverse of this matrix and vice versa. So these, whoa, I'm not on my pen. These are additive inverses. They're additive inverses. So if I add them, I'm going to get the 0 matrix. Ta-da. So if you have two additive inverses and you add them, you're going to get the 0 matrix. Okay. This question we're looking at, if I have the 0 matrix and I add it to something, what am I going to get? Well, we covered that in the last video. I'm going to get the something, right? If I add the 0 matrix to another matrix, that matrix is not going to change. It's not going to change. So I just get this matrix, right? It doesn't change if I added it to the 0 matrix because I'm just adding each element to 0, which doesn't change anything. So that's that. All right. Now let's look at this question. So if I have these two matrices and I want them to be equal, I have some unknowns in here. Notice I have x plus 3, x plus 1, y minus 1, 2y plus 3. So I have some unknowns in this matrix, and I want to figure out what those unknowns, what x and y would make these two equal. Well, if they're equal, then their elements are equal, right? So x plus 3 has to equal 9. Negative 2 equals negative 2. Y minus 1 has to equal 2y plus 5. X plus 1 has to equal 7. Okay, so notice I have two equations with x in them and one equation with y. The one equation with y is great, that's fine. But I have two equations with x. So if these two equations don't give me the same answer, then this is no solution. Okay, if I got, say I solved this and I got 7, and then I solved this and I got 3. So if I got x equals 7 over here and x equals 7, x equals 3 over here, that would be contradictory and this would be no solution. Okay, so that doesn't work. So I have to get the same solution on both of these for these to actually have a solution. So I have to solve both of them. I can't just solve one and say, okay, I found x. I need to solve both of them and make sure they're the same. So let's go ahead and do that. So I'm just going to subtract 3 from both sides on this one. So I get x equals 6. And I'm going to subtract 1 from both sides. So I get x equals 6. So I did get the same solution, but that's something to watch out for. You can't just say get x equals 6 over here and say, okay, I know that x equals 6. I don't have to solve this one, because if this one turned out to be 5, then I have no solution. So just something to bear in mind. Okay, So now over here, I'm going to subtract y. I'm going to subtract y from both sides. So I'm going to get -1 equals y plus 5. Subtract 5 from both sides. So I get -6 equals y. So I get x equals 6 and y equals -6 are my solutions. So if I put those in here, then I would get this, these two would be equal, right? If I put 6 in here, I'd get 9. If I put 6 in here, I'd get 7. If I put -6 in here, I'd get -7. If I put -6 in here, I would get -12 plus 5, which is -7. So I get the same thing, right, on each side if I plug in those numbers. So that is how that works. That's the end of 12.1. See you guys later. Let me know if you have any questions. And yeah, I'll see you later.